Hi. So hi, folks. I will start introducing myself, and then I'll present some news regarding Semaphore and our future plans. So I'm Cedoor. I work as a software engineer with the PSE team. And in the past years, I have mainly focused on improving the developer experience of some PSE projects. I'm talking about what Semaphore is, Semaphore v4, so some news, and then our roadmap. So first of all, Semaphore, as far as I know, is one of the simplest client-side zero-knowledge protocols. So the core circuits only contains 22 lines of code without documentation and like empty lines. Generating a proof only takes less than 1 second on browsers, and verifying a proof on chain only consumes less than 300,000 units of gas, which means like around 5 cents on Arbitrum. But what is it? So Semaphore is a zero-knowledge protocol that allows users to prove their membership in a group and send messages such as votes or feedback without revealing their identity. In addition, it also provides a nullifier mechanism to prevent users from reusing existing proofs. So Semaphore is basically a general purpose protocol, so you can use it for any use case where you need a layer of privacy. We have been working on Semaphore for a few years now, and we have mainly focused on developer experience until v3. But with the latest version, v4, we also focused on interoperability and efficiency and on-chain costs. In particular, we have made 2 important changes. We have a new identity schema, which uses EDDSA key pair, and we have optimized the data structure for groups. So let's go a little bit deeper. We replaced the whole identity schema with an EDDSA key pair. EDDSA is one of the most efficient public key cryptography algorithms used in zero-knowledge circuits, and it makes the new version of Semaphore much more compatible with other existing protocols which use EDDSA. In the old schema, the public commitment, which is like the public identifier of the Semaphore identity, was a Poseidon hash of a secret. In the new schema, the public commitment is the Poseidon hash of the EDDSA public key. And in addition, it also allows users to sign messages and verify signatures inside and outside ZK proofs or secrets, which has been and will be hopefully pretty useful for some applications like Zupass, which uses Semaphore v4. So then we optimized the old data structure, the incremental Merkle tree, and we created a new data structure, which is based on the old one, the lean incremental Merkle tree. So just small improvements that made it much more efficient, especially when the tree doesn't have many leaves, so for small groups. The key improvements are 2. 0 hashes are no longer required, and the tree grows dynamically now. So 0 hashes. I just want to show like the difference between these 2 trees. In the old implementation, if the parent node has 1 child, it will be calculated as the hash of that child node and the 0 hash. In the new implementation on the right, the parent node can actually equal the child node itself. So no need to calculate any hash in those cases. The second important change is about the dynamic depth. In the old implementation, the tree has a static depth. Each insertion needs to update a number of nodes which equals the static depth of the tree. And in the new implementation, the tree depth grows with the number of leaves, which means each insertion would only require updating a number of nodes proportional to the current number of leaves. So this is quite complex, so please, if you want to know more about this data structure, go to the paper we published a few months ago in the ZK repository below. Finally, what we would like to do in the next months, we would like to have a new explorer, which people can use to see on-chain groups, and which admins can use to create and manage groups. We would like to work on a new version of RLN, which is pretty similar to Semaphore. They share the same code, but RLN works with an additional layer to prevent spam. We would like to add additional tutorials to the documentation and possibly have like specifications for Semaphore v4, something that people ask us a lot of times. We will also explore and consider new improving systems, of course, and try to keep ourselves updated on the latest technologies to improve the key requirements of the protocol. So some links you can use to connect and ask us any questions. Yeah, thank you very much.
Thank you, Cedoor. Any questions? Oh, there's one there. Do you want to give it a go? It's on your side.
Hello, Test. Thank you for your speech. It was good. I'm just curious to know more about Semaphore's business model. The tech sounds amazing, but I'm curious, is there a way to generate a profit from this?
No. I mean, we are funded by the Ethereum Foundation, and we are not thinking about any way to make profit.
Okay, thank you.
I think we're also not allowed to speak about profits, just from what I heard.
Okay, thank you.
Okay. Hi, I was wondering, to upgrade or migrate from previous version, does that mean like pre-existing project need to generate new identities?
Yes, yeah. You need to generate a new identity, and one way is to derive the secret of the new identity of like the Semaphore v4 from the identity of Semaphore v3. So using the same secret and deriving the private key from the previous secret.
I have a question for how the protocol works. Do all the nodes need to be online at the same time?
Where are you? Sorry.
Oh, sorry.
Okay.
Hi.
Hi.
Do all the nodes who want to take part in this protocol need to be online at the same time, or is it possible to establish a group without all the participants seeing the other participant at any point in time?
Can you repeat your question? Sorry.
It's about the liveness of the participants.
Yeah.
So can we establish a Semaphore-based communication, for example, even if some of the nodes are only online for a certain short period of time, or do they all have to be online at the same time to calculate these secrets?
Yes, they have to be online, yes, on-chain at the same time.
Okay. Thank you.
Any other questions? Oh, we have one at the front row here.
Hi. What are the advantages of using the lean IMT now data structure for like the the depth of the tree?
I think one advantage is that with the old static, with the old incremental Merkle tree with static depth, we had a range of supported tree depths from 16 to 32. And even if the group is small, like with 10 members, you had to use a Merkle tree with a static depth, which was like 16. So bigger.
So it's storage then?
Yes, for storage, and like the generation of the proof as well needs more time because the circuits has more constraints.
Okay, I see. Thank you.
Yeah.
Okay, we still have some time for questions if you have any.